Hi, this is Dale from Gratronics Electrical. We've replaced the consumer unit now, and one of the first tests we're required to do before we switch on the main switch is to carry out an earth fault loop impedance test to ascertain the good connection to earth. This system here is a protective multiple earth, or TN-C-S. Originally was a TN-S system where the earthing was provided by the sheathing of the lead, and it has been changed, and you can see that this conductor here connects back to neutral, so it has been changed at some point to a PME or a TN-C-S earthing system. Carrying out the earth fault loop impedance test using the Fluke 1653B, we obviously need to select loop on the tester, ensure that we've got a L-PE selected here. That's the earth. We can change it to prospective short circuit current, which we're not really interested in at the moment. So, and it requires a 3-lead test, so we need 3 leads connected in to the unit. I prefer to use the crocodile clip for the earth. It's nice to click on, fasten onto the earthing conductor, and just use the ones for the live and neutral. It's always important to wear extra safety equipment when doing this test. It is a live test, so I tend to wear gloves and goggles. I'm going to norm my test leads out first, so I'm going to use something of negligible impedance, for example the main earthing terminal. I'm going to get my test leads, null them onto there, and see what happens. Sorry about that. Okay, this is obviously okay. My lead zeroed out. Now what I need to do is remove the earthing conductor, a screwdriver. It's important that the supply is switched off if you're removing the earthing conductor. Sorry about the shaky camera. For those of you wondering where the gas main protective bonding conductor is, it's actually connected into this block here, so we do have bonding for the gas, although it's not showing on the earthing conductor. There's a little bit stiff there. So we need to connect one of the test leads onto the earth, good connection, and we're going to put our probes onto the top of the main switch, which is obviously the live part of the main switch. I'll try and get a good camera view for you. Neutral first, and then onto live, and then press the test button. Okay, and we have a earth fault loop impedance of 0.11 of an ohm. With it being a TN-C-S system, we expect to achieve a value of less than 0.35 of an ohm, and I'm going to just repeat the test. It's always good to repeat it, and we'll take the higher of the two readings. And we've got 0.11 of an ohm. So that's an earth fault loop impedance test. We're going to replace the earthing conductor. Always a little bit of a difficult job. Okay, make sure that's nice and tight. Next test for us to carry out is the prospective earth fault current. with this tester I don't need to alter anything at all. I just put my crocodile clip onto the main earthing terminal again. This time what we're doing is we're introducing any other parallel paths to Earth. So that includes any water, which is obviously in turn connected to the gas, and any other parallel paths that might be to Earth. And we're going to carry out this test. Now, again, neutral first. This is a live test, and onto the live and test. And we've got 0.12, which in theory shouldn't actually be possible because we've actually introduced more parallel paths to Earth, so that reading should have been either 0.11 or lower or equal to, but we'll try it again. Maybe just my connection onto these terminals themselves, and we'll try again. Yeah, exactly the same. Next, we're going to carry out the prospective short circuit current, and that is just a 2-wire test on the tester. So I can remove the green one, and I've just got my 2-wire test. I've selected prospective short circuit between live and neutral, which is indicated on this display. And again, a live test, neutral and live, and test. Okay, I've got a reading here of 10 kA. You can see. So that would suggest to me we are pretty close to the local transformer here. That's done it again, exactly the same. 10 kA. People wonder that these circuit breakers have got a 6 kA value, and it's showing in a rectangle by 6,000. That's the maximum fault current they can safely disconnect. But we've got a prospective short circuit current of possibly up to 10 kA. Don't worry, boys and girls, the cutout fuse is good for prospective short circuits of up to 33 kA. So we've got plenty of safety built into the cartridge fuse, which is on as a BS1361 type 2B, and it's indicated as 100 amp. And that's that really. We're safe to switch on at this point, and then we'll move on to ZS values and RCD testing.